Okay, this is number 2 from the Chapter 9 Orgo test. After reading number 2, I identified a couple typing errors, so I apologize for those. I do believe if we're reacting this with chlorine, then this is not bromo, this is chloro. And it started off as cyclohexene, so that means this is cyclohexane, not pentane. So this shouldn't be this should be hex. So that's definitely, those were definitely mistakes. So fixing those first. All right, so this was 20 points. I'll go through this whole mechanism and I'll identify where the points would have been assigned. So it says, we're going to start off with 3R23 dimethyl cyclohexane being treated with chlorine. Okay, so we got cyclohexane. We've got 3R23 dimethyl. So we've got, I'm just going to put our double bond here. That's really arbitrary, but I'm going to put it there, which means that 2,3 dimethyl would look something like this. I'm going to make that 2 and this 3. So there's 2,3 dimethyl. Now it says 3R, so I need to figure out if this methyl is a wedge or a dash. So I believe that proper assignment of priority would go 1 to this carbon, 2 to this carbon, 3 to this carbon. So that would look like 1, 2. That it looks like clockwise right now if I did that. So I need this to be a wedge for this to be R. So I got a wedged methyl on 3, and that would give us 3R23 dimethyl cyclohexene. We're going to treat it with chlorine. Okay. So I would start with an arrow with the pi bond attacking the chlorine, and then an arrow that would show the bond breaking between the chlorines. And then that would give me my intermediate, which would have my chlorine attached to the less substituted carbon, and I would have a positive charge on my carbocation, or a positive charge on my more substituted carbon, leaving me with a carbocation. And then I guess I would also have chloride as a byproduct, but I'm not going to write that. The next step, since we are in a water solvent, I would expect water to act as the nucleophile, and I would expect an attack to the carbocation, and I would have a charged intermediate with my wedged methyl again. I would have now oxygen attached, well, my water attached. And again, this would be a positively charged species. And then again, here I have my chlorine. Then I would, in the next step of the mechanism, I would expect another water to come and deprotonate one of these hydrogens, which would stabilize this structure. So coming in with another arrow, I'm going to deprotonate this hydrogen, and then an arrow that will show electrons dumping back onto the oxygen. So that will leave me with something that looks like this. So right now I've got OH and I've got Cl. Okay, so I believe this is my 1s2s3r 1 chloro 2 hydroxyl 2,3 dimethyl cyclohexene or hexane. So let's double check to make sure that is true. So I would have 1s. So right now, if I were to rename this, I would put number 1 here since it's got my Orgo group, and then I would number it this way. So 1, 2, 3. So if I want this to be an S, I believe this needs to be a wedge. That would give me priority 1, then 2, then 3. That looks like counterclockwise. So that would definitely be a wedge. And then I would want my OH to be S as well. So I would want, let's see, priority would go number 1 on the oxygen, 2 on this carbon, 3 on that carbon. So that looks clockwise right now. So if I want that to be S, I need this to be a dash. So that means this methyl is a wedge, and that would make this a dash for my OH, and then my 3R hasn't changed, so that's still R. So here's my current product. I've got, again, 1S, 2S, 3R, 1 chloro, 2 hydroxyl, 2, 3-dimethyl cyclohexene. And then we're going to treat this with sodium hydroxide being an E2 mechanism. So hydroxide acting as a base. So I'm looking for my leaving group. I think my better leaving group is the chlorine. I guess hydroxide could be a leaving group too, but I would need to find a hydrogen that's anti-periplanar to these leaving groups, and that would be, the hydroxide doesn't have that. I would need a hydrogen on a wedge on either this carbon or this carbon for the hydroxide to leave, and I don't have that. But for the chlorine, I need a dashed hydrogen, and I don't have that on this carbon, but over here I do have a dashed hydrogen. And there's my hydrogen that my base will attack. So with an arrow, I'm going to attack that hydrogen. So I'm going to show another arrow forming the pi bond, and then my final product is going to look like this. So my wedged methyl on 2, my dashed hydroxide, and then my pi bond. Again, sorry, I got to show chlorine leaving. So another arrow with chlorine leaving. So here's my final product. Now to name this, so we're going to call this, this will be number 1. We're going to go 1, 2, 3, 4. So I would call this, and that was S, right? So this is 3S, this is 4R, and then we got 3-hydroxyl, and then 3,4-dimethyl cyclohexene. So this is 3S, 4R, 3-hydroxyl, and then 3,4-dimethyl cyclohexene. So there's your name for our final product. Okay, so this was worth 20 points. So let's start with all of our arrows. Let's do every arrow is going to be worth 2 points. So we've got 1, 2, 3, 4, 5, 6, 7. So there's 14 points. So each proper arrow, 2 points, 4, 6, 8. Sorry, there's 10 right there. There's that little arrow there, 10. And we got 12, 14, 16. So we have 16 points just with the arrows. So we're going to do that. So 16 points with the arrows. That leaves us 4 more points. So let's do 1 point for the proper name at the end. And actually, let's do 2 points. 2 points for the proper name at the end. So with 2 more points. So let's do this. With 2 more points, let's go 1 point for drawing the proper starting molecule, and 1 point for the ending molecule. So I gave a lot of points to the arrows for the mechanism, and then I gave fewer points to the nomenclature and the drawing of the structures. Okay, so I'm going to end the video here. I'll start another video for the rest of the multiple choice.